Target 28, a process called completing the square. And in this process, we're going to be changing it from standard form back into graphing form. So we have these now in this standard form that we're used to. We're going to switch it into that form that we like, which looks like this, where we have a times x minus h squared plus k, and that's what we're looking to change it into. Right now it's in standard form. So in looking at this, if we have this first equation, which is x squared plus 6x plus 7, it really comes down to a three-step process. This completing the square process has to do with these three steps. If you want to write these down, pause the video, you can do that, but basically it's all about half the middle number, which is the x term, then squaring that new number, and then subtracting that from the last number, which is called the constant. So if you want to write down those three steps as half, square, subtract, that's what we're looking at. What I mean by that is this. We take half of this x term, so this is the x term, the middle number, half of it would be 3. I put a 3 right there. Then I look at this and say, oh, that would give me x plus 3 squared, because I'm turning it into graphing form like it is up here. So x plus 3 squared. Well, then square that number. 3 squared is 9. Then I take 9 from the last number, and 7 take away 9 is negative 2. And I have just changed it from standard form into graphing form by using the technique we like to call half, square, subtract. Say it with me. Half, square, subtract. Now when we're doing this half, we mean half of the middle number. When we're doing this squaring, we mean you'd square that new number. And then you subtract that number from the last number that's in your equation. We call that the constant. So here we go. Over here, in the second equation, it's x squared plus 4x plus 11. Half is 2. It's plus. So it's x plus 2 squared. Squared is 4. Subtracted from the last number, you end up with plus 7. There is my equation. Now, we haven't followed the directions completely because we're supposed to be stating the vertex. But I wanted to show you the process. So the vertex of this would be negative 3, because that would make this part 0. So negative 3 and then negative 2. Some of you just remember it's the opposite of whatever's in there. So the vertex would be at negative 3, negative 2. The vertex here would be at negative 2, 7, because there's a 7 back there, and this would be a negative 2 situation. Now, some people get kind of crabby when they see stuff like this, because then they're like, oh, what do I do here? There's no number on the end. Well, fine. Put a plus 0 on there, and don't be so crabby, and just do it the same way. So then half of this would be 5, so I do x plus 5 and then squared. 5 squared is 25. Taken away from 0 is minus 25. Boom. Done. And we're good. Okay, last one over here. Ooh, another place people might get crabby because they go, oh, what's half of 7? Well, don't worry about it. It's 3.5. It's not that big of a deal. So I end up with x plus 3.5, and then I have to square it. Well, don't be afraid of squaring 3.5. Just go 3.5 squared, and you end up with 12.25. And then that's the number you're taking from 2. So minus 12.25. Oh, I don't know what that is. 2 minus second answer. Boom, done. It's negative 10.25. So put that right here, negative 10.25. And I've got my equation now in graphing form. Again, stating the vertex would be negative 3.5 comma negative 10.25. And there we go. Over here, the vertex would be negative 5 comma negative 25. And I'm good to go there as well. So again, it all comes down to this process. Half, square, subtract. Now, if you want to see that as far as the notes go, then the notes are just simply this right here, where you take half the middle x term, square that new number, subtract it from the constant, write it in graphing form, and you are good.